Good morning, everybody. Say yesterday, after looking at the Flipgrid videos that you made and your answers to the question about the impulse game, I felt like you didn't fully understand how Newton's third law of motion works. So there's a couple things you need to understand just going into this. When we talk about equal and opposite reactions, really what we're talking about is equal and opposite forces. So if there's a force going this way and it hits something, there is an equal and opposite force going the other way that hits back. So think of them as equal and opposite forces. Maybe that would be an easier way to help you understand it than to think about equal and opposite reactions. So what I would like to do for you today is I'd like to replay this video. Drag that on there. Replay this video about the equal and opposite reactions with these carts. Let's make this big. Okay. So what you're going to see in the first picture there, or the first image, you've got two carts, and we'll call the cart on the left, we'll call that cart 1, and the cart on the right is cart 2. And in this situation, the carts they're equal in mass, and they're traveling with an equal speed, so they're equal in every way, and they're going to hit each other head on. Okay, so watch what happens. Boom. Okay, so because they hit each other with an equal and opposite force, the cart on the left sends force through the cart on the right, and the cart on the right sends an equal and opposite force back to the cart on the left, and they move apart with an equal speed, but in the opposite directions than they were traveling at the beginning. Okay, so in the second situation, it's going to be a little bit different. Slow motion is maddening. Okay, in the second situation, you've got the cart on the right is going to be sitting still, but it's equal in mass to the cart on the left. So watch what happens when the cart on the left hits it. And go. Boom. And okay, now you're going to see that the cart on the right, it was sitting still, but that cart on the left transferred its force into the cart on the right. The cart on the right is going to keep going in the direction towards the right. Watch what happens to the cart on the left. And the cart on the left sits still because all of the force from the cart on the left was transferred into the cart on the right. And so that caused the cart on the left to stop, and it caused, we say the momentum, all of its momentum transferred into the cart on the right. Okay, a different situation here. The cart on the right is going to be heavier than the cart on the left. And boom! Like my sound effects. Okay, now interesting what happened there. So when they hit against each other, okay, some of the force from the cart on the right is going to transfer into, I'm sorry, some of the force from the cart on the left is going to transfer into the cart on the right. It's going to cause it to be in motion, but the cart on the right isn't going to go very fast because it's heavier. And then the cart on the left, it was hit with an equal and opposite force, so it's going to go backwards, but it's not going to be going as fast as it was when it was moving forwards. It's kind of hard to see because it's moving in slow motion. Okay, now they're going to, I'm telling you that, okay. Now, totally different situation here now, or opposite situation anyway. Now what we've got is the heavier cart is going to be the cart on the left. The light cart obviously is the cart on the right. So the heavy cart is going to run into that cart that's just sitting there on the right, and watch what happens to the motion. You can probably predict. And boom! Now watch how fast the cart on the right travels. Okay, and the cart on the left, the heavy cart, it kept moving forward, but it wasn't going as fast. Okay, so it hit the cart on the right, and the cart on the right hit back with an equal and opposite force. The cart on the right was propelled towards the right because of the force of the cart on the left. The cart on the left kept going because it was hit backwards with that equal and opposite force. And so when it was hit with that force backwards, that slowed down its forward motion. So that's why that heavy cart keeps going forward. Okay. Heavy cart hitting a light cart head on. So now they're both going to be in motion. And I love freezing it right at the point where they hit. Okay, now predict what's going to happen. Okay. Boom. Now look how fast the cart on the right went. And you can see the cart on the left is moving backwards just a little bit, but it certainly wasn't going very fast. So I hope that helps you understand. Oh, we do not need to watch that again. I hope that it helps you understand how Newton's third law of motion works. It's a matter of, I don't like that lady's head by me. I'm going to move myself up there. It's a matter of equal and opposite forces. But if you, and I think that will help you understand how it works better than when you're thinking equal and opposite reactions. Okay, so I've attached, we'll do something a little bit different today. I've attached a quiz question about this video. Don't worry, it's not hard. So I'm going to have you answer the quiz question today, and then there will be a notebook assignment tomorrow. Ciao, everybody. That means goodbye in Italian, in case you didn't know.